So today's homework is page 35 and it's down here figure 2.37. Okay, so this is the question, this is the information given. Now obviously we have a solution here. Try and cover over that. We want that gone because again we want to use our heads now rather than just copying what we see. Alright, so try and use our heads by reading the red box and our question, the given information, and we'll go from there. So the plan of a base of a tetrahedron is shown in figure 2.37. Okay, edge AB rests on the horizontal plane. Draw the plan and elevation of the solid. Okay, so this is the information given and we're going to get that going there. So this is the plan of it. Now it's an incomplete plan, but it's the starts of it anyway. Alright, so what we're going to do, excuse me, I'm going to pop in my X, Y line to start with. Alright, now we have a 45-degree line. So they're telling us from here we have a 45-degree line coming out. So again, pick anywhere, just keep it over towards the Y there. And we are 60 millimeters away from here along that line. So measure back 60 millimeters. That is going to be B. And A is 75 away from there. There is A. Alright, now again, at this stage I would not heavy anything in. I know they have in the given image there. I wouldn't heavy it just because some things might be hidden, some things might move, we don't know exactly. C is out here, we just know it's 65 away. Now straight away, when it tells us 65 away, we know the tetrahedron has to be moved. It's after being moved because a tetrahedron is an equilateral. It's based on an equilateral triangle. Okay, so we need to find the plan of it basically. All right, so what we're going to do, it's telling us that AB rests in the horizontal plane. So straight away we know we're going to have to do an auxiliary. All right, seeing as we're only given this information, it's going to be an auxiliary elevation out here. So we're going to have an auxiliary elevation out here somewhere. All right. So what we're going to do is we're actually going to do the plan of our tetrahedron here, starting us off. Okay, so keeping it easy. Again, it's based on an equilateral triangle, so all sides are the same. So just get my length of AB, swing an arc out here, move over to B, swing an arc out here. There we have our C. Again, it's not where they want it yet. We're going to do it anyway. So we're going to do the plan of this tetrahedron as if it sits on the ground. Now, there's my object. Now we need to find the center point, midpoint. So we're going to bisect any two angles. Compass, any radius, swing an arc. Okay. Move it out to where the arc hits the line. Swing your two arcs, give us our X. Join B, the X, there's the first angle bisected. Go and do it again. Any of the other corners. Oh, after on a slip there, sorry. Go from the other corners. And bisect that out. Alright, that's splitting the two angles there. I'm going to call that O. Okay, there is our apex of our tetrahedron. Join that out to C. Alright, so here we have our tetrahedron, the plan of it. Now what we're going to do is we're going to take that out over to our auxiliary. So we're going to look along the line. So if you look along a line, you get it as a point of view. If you look along a line, so we're heading it out at 45 degrees. Now, out here, sorry, should take the others with it, would help, wouldn't it? So taking C out as well, and we're taking O out as well. Now we're doing them light. Because we're doing them light, it's all right. Okay, excuse me. I'm going to pop in my X1, Y1. There's my X1, Y1. Now, we have AB here. As we looked along it, it's now a point view. There's A and B. C is out here. It's on the ground. And O is floating up here somewhere. Alright? Now, tetrahedrons based on equilateral triangles. If we go and look at our x1, y1, our line CO is parallel to it. So if we have a level line in one view, it's a true length in the other view. So a level line there is my CO. True length of that is A to B or B to C or whatever you want, but it's 75 millimeters. Put it at C. Swing my arc. There is O. Again, pop it in nice and light. There's my auxiliary elevation of my object, of my tetrahedron, but it's sitting on the XY. It's going to get rotated now. Now, that's your basic construction setup. Time to do our rotation. So now we can go back to the question. And it says A to C is 60 millimeters. So, I now get my 60. On my compass, get my 60 on my compass, go to A, and I'm gonna swing my arc. So if we flip this back, rotate this on A to B, all that's gonna happen with C is it's just gonna come back along this line, like this way, because all that's happening is it's pivoting up the way. All right, so C just moves back. So therefore C is gonna cross that line. So there is C, where it's actually in position. So I am going to, for this, heavy C to A and B to C, just to show us that's where it is. Now O is out here, not too sure where it's moved to. We're going to leave it still for now. So we know C has moved up. Excuse me, sorry. C has moved. So what we now do is we send C up into our auxiliary elevation. Okay, so C has gone up into our auxiliary elevation. It's rotating on AB. So we put our compass at A and B, stretch it out to C. There's my C. And we just rotate it like they're telling us. It's rotating up. C is brought up. Rotated C. Where they cross over. That is where C is actually based. So I can heavy that in. A, B to C. We need to find O. So we have the line here moved up. We go back and we get our compass at A. And this time we stretch it. Sorry, I'm blocking the camera there. A to O. And we rotate it back. It's going back here somewhere. Now, took this, moved it, took C up, moved it. The only one we haven't touched are these two. So now we're going to go C to O, which again is our true length. Put it at O, swing the arc. Now, as you notice, it hasn't crossed yet. So go back to where we had it before, rotate it out. Just yours, just extending it basically. And there we have it. That is O. So O goes to A. And O is heading out to C. Alright. My apologies. I'm just after noticing what I'm doing there, my mistake. So I'll do a quick rub out here. So sorry about that. I was noticing it looked just a tad longer than it should have. Okay, my apologies. So jumping back there again, we're rotating A to O around. Get our distance C to O. There. And put it at C. My apologies, I put it at O by mistake. Put it at C. Swing the arc. Where they cross over. That is where O is after being moved at. Alright, now we can have it in. So, it's in the correct place this time. Now there is my triangle. Alright, so that's it in its rotated position. Now I can just get O, send it down. Alright, all that's happened is O got rotated back. So we just take this one here, C to O, and we just send it back. Where it crosses here, that is O. Now you can heavy O to A, O to B, and we go back to our usual pencil method. Alright, this is the way we're looking for the plan. Hits off C, hits off O. We can't make it to AB, therefore AB must be hidden. Alright, that's it in plan, and just send it up now into elevation. So B is on the ground, A is on the ground. We take our heights from the auxiliary elevation, so from the x1, y1 out to where C is. Step it up. Extend my x1, y1 here. Take the height then from the x1, y1 up to O. Step it up. And there we have C and O. Excuse me. So we're looking in this way now. So O to A is hitting each other, so we can maybe that in. Or I should say hitting the pencil. The pencil gets O to C, no problem, or A to C. Alright, so therefore it must be able to catch this line, which I haven't heavied in yet because this is heavied. So it must be able to hit that one. O to C. Alright, it's also catching B. So we've B here. O to B. A to B at the front, that's seen. And then our last one is A to C. That's at the back, so therefore that is in detail, broken line. Okay, so again, when you're doing this question, try and avoid looking at the solution. Alright, that is page 35. It's figure 2.37. Okay.